So let's discuss the code of the quicksort algorithm. So let's call the quicksort on the given vector. We will pass the array and low value is 0 and high index is 8. Okay. Now we will define our quicksort function here. Quicksort, and we will get the argument as vector of int, and we will get a low value and a low index and high index. And what we will do, we will see if low is smaller than high. Then what we will do, we will apply the partition function here, in which we will partition function in which we will pass array and low value and high value, and again we will apply the quicksort to the two array after the partition, and we will pass low and p minus 1 and quicksort array p plus 1 and high. Okay, this is smaller s. Okay, now let's define our partition function. So partition function will return the int, that is the index. So we will accept the vector of int as an argument and low index and high index. And then in our case, our pivot element will be uh, element which is present at high index. And what we will do, we will take another index which will be pointing to low minus 1, because initially we didn't run our code. So we will now run for int j is equals to low to j is still high and j plus plus, and we will check if AR of j is smaller than or equal to the pivot. So what we will do, we will simply swap the element. So first of all, we will increment the I, and then we will swap the element which is uh, AR of I will be AR of I will be AR of j, and AR of j will be 10. Instead of doing this, if instead of writing this three line, we can also use the swap function, uh, which are defined in the STL library. But for the simplicity, I have writing like this. Okay, so we will swap the ARI and ARJ value, and whenever this for loop will be exited, so what we will do, then we will again swap ARR I plus 1 with pivot element. So ARR of I will become temp, or ARI plus 1 will become AR of I, and AR of I become temp, and then we simply return the I plus 1 index. Okay, this is a simple algorithm, and then we can check out our vector whether it is being sorted or it is sorted or not. So let's print it out, array of I. And one more thing we have to note that we have to pass this by the reference, then only the changes will be updated. Okay, so okay, now let's run the code. Okay, we are getting the array in a sorted order. Okay, so our array is now sorted. So yeah, Yeah, that's all.